We're in the back shop this morning at Diverse Dimensions. We've got a big reverse engineering project in front of us today. What I've got here is a fixture or a buck from a local manufacturing firm that makes wheelhouse liners for semi-trucks. And what we've got here is just one big sheet of plastic gets pulled into a vacuum form machine or a vacuum form tool, and then this one piece will be made into two wheelhouse liners. So after it's vacuum formed into that shape, it goes into another cell where where two robots will come in and cut out these two wheelhouse liners. So what we've got to do today is just reverse engineer this line, the line that's the perimeter that the robot will follow. But before we do that, we've got to do a 3-2-1 coordinate system. Since this client, what they use is a turntable where the operator will load the part in, and then it shuttles into the machine where the robots will cut it out. The robots recognize the pin on that right-hand side as the origin. So that works perfect for us. We've got a pin on that side and also a pin on this side that go into a hole in a slot. So easy 3-2-1 coordinate system. So what I've done already is I've measured the tabletop, I've measured the bushing on the right-hand side, that's a circle, and I've measured this bushing on the left-hand side, that's a slot. So what I'd like to show you guys is the 3-2-1, plus I'm going to take you into the alignment. I'm going to align the ferro arm to the coordinate system. So I want to talk through that a little bit too. But the 3-2-1, simplistic stuff. The 3 stands for the 3 points that make up the first plane. I've actually used a bunch of points on here, but 3 will stand for the 3 points to make the plane. 2 will stand for the 2 points that will form the line. And in this case, I've got a hole and a slot that will form my line. And then we've got the hole on the right-hand side that would be my 1, or the origin of what the coordinate system will use. So I'm going to show you all that. So I've got 4.0 up today. So come on into the software with me and I'll show you how to make that 3-2-1 coordinate system. Now notice on my screen here, I've got my plane measured, and I've got my hole, and I've got my slot. But notice the trihedron over here, this XYZ. I'll zoom around here a little bit just to show where that's at. That is right in the middle. If you can kind of see that right here, it's in the middle of what I've measured so far. Of course, it's the arm. It's the coordinate system that comes with the arm. CAM2 says it's the world. But what I want to do is I want to set the world to be the origin that the robot's going to see. Okay, so let's walk through that in the software here. If I go up to construct coordinate system, and then I run to 3-2-1 right there. What I do first is I select my primary as being the tabletop, and then I turn on this radio button right here. This second area, this dialog box, will show how we're going to set up the line, or the 2 component of the coordinate system. So what I'd like to do is I'd like to set up an axis through the hole and then through the slot, and I want to call that my plus X direction. I've got all kinds of options for that. But what I'd like to do is say that the hole on this side is going to be my origin, and the axis is going right through to the slot here in this direction being positive X. And then I would set my origin to the hole on this right-hand side and say OK. I usually like to name my coordinate systems as well, so let's call it 3-2-1 and say OK. Now notice what CAM2 did is it set up a coordinate system right here, right over top of where that hole is. Okay, I like that. But what I'd like to do is I'd like to fake the arm out. The arm still has a coordinate system that it thinks is 0. Let's move him over to that other coordinate system. So let's go to the alignment menu here, CAD equals part. Now, when I do the CAD equals part, what I'm doing is I'm taking the coordinate system, or the world coordinate system in the arm, and I'm going to move him physically to the origin over here of the 3-2-1. So let's take the measured coordinate system and say the world will move to it. We'll say OK. And then I'll call this alignment 3-2-1 as well and say OK. Now it happened kind of quick in the back here, but let's rotate around a little bit. Notice now my my trihedron here, the arm actually thinks it's here as well. The arm will say, okay, that's my 0 position because I've blended the world coordinate system to this position. But also notice, it might be a little bit tough to see, but right in here, I've got a blue dot yet. What the blue dot represents is the coordinate system of or the device position of the arm. It has to know where it came from before it took off and went to the origin here. So the device position will always stay in your view right here. Now I'll escape out of that. But another thing I like to do is I like to prove to myself and to my client that I'm using his datum scheme. So if I'm saying that that pin bushing for the hole is truly my 0, I want to prove that. So you can see here that it truly is my X and my Y component is starting with a 0 here. And then the slot should have the Y component, of course Z as well, but the Y component will be 0 here too. So truly I'm in a 3-2-1 alignment and I'm bisecting right through that hole and that slot. And that's exactly what my client is doing with their robotic application too. So 3-2-1, super easy. So try it on your own. And don't forget, always use the CAD equals part, or you fake the arm out. Do the alignment of the arm to the origin that you've set up on your coordinate system.